Okay, getting the recorder going so we can save this out. The sitting here with my new outfit, my new rig here. Everything seems to be working great. Done 2 classes so far, nothing is broken down, so I guess we're in business finally. One small change to the schedule. I had initially had the next piece of work, which we'll talk about here in a little bit, due on the 17th. We're going to back off from that and have that due the 21st because it really would have been, it would have just sat there because I wouldn't have a chance to look at it until middle of that week anyhow. So we'll just do the 21st. I have feedback to give you. You should get that tomorrow. I'll be here in my den all day tomorrow, so hopefully everything will go well, and we'll get all that back to you. And so as I said, we'll talk about the next draft here in a little bit, but essentially it's the first draft that has all the different pieces in it on the outline form that you have in the first section of your As You Learn page, which is the outline for the school improvement plan. And so I don't think I called it that. I think on that page I called it the School Improvement Project Outline. Yeah. So we'll talk a little bit more about that at the end this evening. This evening's goal is to kind of introduce the logic for the quantitative methodology and kind of talk about that a little bit. And then next week, when we meet next week, we'll talk about the qualitative methodology and a little bit of mixed methodology. And then the final week, we'll talk a bit about the reporting of data and how you tailor different messages for different audiences and such. So, that's kind of the plan at this point. The rest of the dates that are on that sheet that I gave you are still the dates that will follow. And so the only thing that's changed is from the 17th, we'll jump to that'll bump forward to the middle of the next week on the 21st. Any questions or about that or comments or whatever before we begin talking quantitative stuff? Okay. There are 2 primary forms of analysis and research that we use today, and those are the quantitative and qualitative. They are substantially different from each other, both in what you can do with them and also the sort of the underlying logic set. The quantitative methodology or deductive methodology is based around a logic set that is deductive in nature. The general idea is that we create a hypothesis, and from that we generate a prediction as to a particular outcome, and then we go about researching, building a research project that will allow us to test that particular outcome. The form, as we know it today, really kind of dates back to the middle of the 19th century. Prior to that, it was very much an inductive process for doing any sort of science or any sort of analysis. Was very inductive in that you just collected a lot of information and then figured out what it all meant once you collected all the information. And that served a pretty good purpose for, from the 1200s, 1300s up to the 1900s, the 1800s. But as you begin to have the Industrial Revolution kicking in and influencing culture and society, and problems became much more difficult to deal with, and so as things began to happen in society and culture, it was kind of assumed by a lot of people in the scientific fields that we needed a different way of doing science. That the old way of doing science was too slow and too cumbersome, and we had questions that we really needed answers to that we couldn't use in the old form of inductive science, more, I won't call it qualitative, but more inductive science. And what that kind of led us to was this idea that we had to have a better way of doing it, and it became the foundation for what became to be known as the modern scientific method. And the modern scientific method was based on a couple of notions. Let me share up one of those. Hold on. Okay. We needed answers as to cause and effect. In other words, we needed answers in terms of if I did a certain thing, would it elicit a certain outcome? And we can never really know cause and effect 100% because there are only two ways that we can know 100%. We could either have an infinitely large sample, in other words, look at everybody. And so let's say, like the example that I have on the handout that's up there, that we were wanting to know, is there a difference, or is gender predictive of IQ? In other words, is there a difference between males and females in terms of IQ? And one way of getting at that would be to essentially collect information about everybody that existed in a population, measure their IQ scores or look at their IQ measures, and then we'd know, or who has a higher average IQ, men and women. But that requires an awful lot of effort and is almost an impossibility because you would never know for sure until you had kind of an infinitely large sample. And the other possibility is if, let me give you the classic example of what's called the counterfactual dilemma. Let's say I have a headache and I take 2 aspirin, and an hour later my headache's gone. And so my natural inclination is to say, okay, the aspirin got rid of the headache. Well, I can't really say that because I don't know the counterfactual. In other words, I don't know what would have happened had I not taken the aspirin. An hour later, would the headache still have been gone? And since we can never know, 2 different things simultaneously, that's the counterfactual dilemma. So we can never really know cause and effect. We can never really know 100% proof. And so we have to come up with a way of getting as close as possible. And we can talk about probability of causation. As opposed to talking about causation, we can talk about probability of causation. And there are a couple of old, well-known theorems or laws that were known in the 19th century. And one was called the central limits theorem, which dated from the middle of the 17th century and early 18th century. But it essentially said that if you collect and measure randomly occurring instances of something, those, and then see how those things are distributed, you'll discover they're distributed in what's called a normal fashion, or that classic bell curve thing that you think about. And that's not a mathematical concept, it's purely a logical concept that if you collect enough samples of something that's randomly occurring, it will be distributed in a normal manner. And the reason it's called a normal manner is because that's what would be normal. Not that normality has any sort of mathematical concept to it. It's just that would be the normal way things occur. And intuitively, you kind of know that because we're a lot more alike around those things than we are different. And so most of us around most things are sort of compressed in the middle someplace, and then the extreme outliers are, just that, extreme outliers. And so this bell curve, this normal distribution, is an outgrowth of what's simply called the central limits theorem. And the second thing known at that time, which also dates back to the 17th century, holds that for if you randomly sample a population, that sample will carry the same probabilities and the same characteristics as the population. In other words, if you take a random sample from a population, that random sample will carry the same probabilities and the same characteristics of the population. Now, kind of important to the modern scientific method, because that means whatever we find out about random samples, we can generalize back to the population. It works the other way around too. What we know about random samples, we also know about the population. And so what we find out about random samples, we can generalize back to the population. And the reason it's called the law of large numbers is it means the more occurrences we have and the bigger the sample sizes get and the bigger the n, the way in which random samples mirror the population becomes more and more perfect. Now, when you take those notions and you apply it to sort of the modern scientific method idea, and let's say we have a population of some sort, and we measure something about that population, and we'll just say that n is infinity minus 1 or whatever. In other words, it's a very large population. And I guess that doesn't really look like infinity, does it? When we measure that population on something, maybe we come up with a population average of 150. So whatever we're measuring, the average of that measure is 150 across that population. If we go in and randomly sample that population twice, and we'll call them groups A and B, we should find that on that same measure, they're also average 150. And essentially, it's just logical that if one is a random sample and the law of large numbers work and they mirror the population, then the other would be too. And so, did that not share up? It didn't, did it? All right, let me go back over there. How about now? Now I see it. Yeah, it didn't share for some reason. That if we once again, if we start with a population, say an n of slightly less than infinity, and we know the average for a particular measure, whatever it is we're measuring, is 150 for the population. Then if we do two samples, random samples, A and B, then we kind of get to the point where A and B we know will have the same characteristics, or the highest likelihood is they'll have the most same characteristics as the population. So we'd expect the measures on that within those samples to be average of 150 also. And let's say these samples are 100. So they're equal to begin with. And then we do something with the groups. We do some sort of treatment of sorts, so we do something different with the two groups, so that there are two different treatments. And you might think about this as being sort of the experimental group and the control group. And so maybe the control group gets status quo and the experimental group gets something new or something different. Well, then we measure them again. After that, we measure them back on the same thing we measured before. And we discover that group A, the experimental group, now their average is 120. And group B, their average is 150, 150, as it started with, whatever it is we're measuring on. And so there's a difference of 30. On whatever that measure is. So the logic of the modern scientific method would be to say that the difference in treatment is the cause, and the difference of 30 is the effect. And so we have cause and effect. Now there is a problem here, though. There is a problem. And the problem has to do with, is 30 a real difference? Or is it just random fluctuation? And that's where the modern scientific method had a hole in the logic, was that we didn't know whether a difference of that magnitude of 30 could be a real difference or not. And so here's why. When we measure something, we know that part of what we'll see is the true score, and part of what we see is error. Because there's no such thing as a perfect measure, there's no such thing as perfect responses, there's just no such thing as having a perfect way of looking at something. And so we know that there will be, when we observe a score or an outcome, we know that part of that will be true, but a component of it will be error, some sort of error, bias, error, whatever you want to call it. But even more problematic is that some of that error is random, just normal differences between subjects or normal differences between people. But part of that error can be either systemic or the measure of an effect based on a cause. Now, what's a systemic error? Systemic error is the fact that a gender, male and female, or age, or urban versus rural, or whatever, that there are differences that are just related to different characteristics of people. But there's also a possibility that this, what we call systemic error, could also be error that is caused by, or appears to be caused by, some sort of treatment difference or something that we did differently with groups. And so when we go back and look at this 30, we have to ask the question of this 30, how much of it is random and how much of it is systemic or effect based on treatment. And that was the problem that the modern scientific method created. How do we know? How do we know whether a 30 is a real difference? How do we know whether a 10 is a real difference? How do we know whether 40 is a real difference? And so we were left with a scientific methodology that had promise, but we needed to answer an essential question. And the essential question was, when is a difference a real difference and not just a random fluctuation, not just random outcome? And so that led to the development of the logic around statistics. All statistical logic has at its root the idea that we can compare an observed outcome and an estimate of random error. And so every statistical technique that's used to analyze quantitative data has as its heart looking at error, E-R-R-O-R, to see whether what's the relationship between observed error and an estimate of random error. And that becomes the fundamental structure of all statistical analysis. Now, the other component of all statistical analysis is the fact that this normal distribution is the way in which things are distributed that are random. And the larger the number of things you're looking at, the better the distribution is. Now, at some point, we can identify the percentage of cases in different slices of this distribution, so much so that we can identify, what represents the middle 95%. What scores or what values of some statistic with some formula like this where 95% of those cases will lie, leaving 5% in the outlying pieces. So if you think that way, 2.5% on one side and 2.5% on the other side. And so that brings us to the concept of significance. And all significance states statistical significance is generally defined as having less than a 5% chance of the outcome being due to random error. And so if we go back to our little distribution we just looked at, that means that all of this area in here, this middle 95%, this is all considered to be random error. And these two slices out here are considered to be either systemic error or effect due to treatment. And the same thing over here. So when we say something is significant, there's a significant difference, there's a significant relationship, there's a significant whatever. All we're saying is that there's a less than 5% chance that that outcome is due to random error. Because the vast majority of the outcomes will be random error from these different statistics. And so the only real difference in terms of statistical analysis is what does the experiment look like? How many groups are there? What kind of data are we collecting? But we're always looking for statistical significance when we're dealing with quantitative data and quantitative analysis. Now, we're always starting with a hypothesis, and the hypothesis will lead us to predict a particular outcome, make a prediction. We'll describe or design an experiment that will allow us to look at that prediction, to measure that. And then we'll either have a significant outcome or not have a significant outcome. We'll never know for sure cause and effect. We can only know with a certain probability that cause and effect might exist, but we can never know absolutely whether we're looking at cause and effect. But the trick is always that we are making inferences based on the logic that these groups were randomly drawn from a larger population. And so whatever we know about the groups applies, we can generalize to the larger population. And that's the strength of quantitative logic, of quantitative inquiry, is that whatever we know about groups, if we've designed the experiment well and if we've have fairly random sampling, whatever we know about the groups, we can apply to the larger population. And that's why typically policy decisions, programmatic decisions, money decisions are almost all made based upon quantitative analysis. Because we can always generalize results back to a larger group. So what works in one school among a couple of fifth graders, we can generalize back to the entire system among all fifth graders. I mean, between a couple of fifth grade classrooms. And that's the reason we do quantitative inquiry. That is, its basic strength is that ability to generalize back to a larger population. And that's why most policy decisions are made on quantitative data. Yeah. The strength of qualitative data, on the other hand, is that it is very limited amount of subjects, almost no thought about drawing them randomly, but that we collect a deep well of data, a deep well of information on those subjects. And so qualitative research is done for understanding. Quantitative research is done for the ability to generalize back to a larger population. And mixed methods research, which we'll mention a bit next week, is designed to take advantage of both of those strengths. But with strength comes a weakness. We can, in quantitative research, we can only answer the question we've asked and collect data for. With qualitative research, we can all apply it to the individuals that we drew data from. And so there are strengths and weaknesses in both directions. Questions, thoughts? Okay, next subject. The next project, next draft, not project, next draft. Once you get feedback from this action plan element, you'll be ready to go in and begin to construct the narrative for this overall project. And this next draft due on the 21st, I'll actually begin to look at it from the sense that that's a manuscript that's emerging. And so the introductory piece, the first part of it, the rationale, introduction, problem statement, and description of intervention, description of setting, that will all be in a narrative, following the outline that you have on As You Learn. Lit review piece, you'll move from annotated sort of bibliography, which some of you had, to a kind of a narrative component, not kind of, but a narrative component that makes connections in the literature based on sort of common themes or common elements that you've run across. Now, it'll be somewhat limited given the sparse nature of the number of sources I required you to get. More sources you have, more clearly that pops out. But, you know, even at 6 or 8 or 10 sources, you can probably begin to see some themes emerging. At the end of the lit review, there's a summary of what you found in the lit review. And after that, there are implications for what your research, for impact that the lit review might provide for your research. And then the third major component is to take your action plan with feedback and begin to carry that into the construction of a narrative for the methodology section. And so this next draft will be headed in the direction of a final draft. This will still be pretty rough probably, and that's okay. It's designed for me to get a decent look at, give you some feedback fairly quickly, so that the first final draft can be ready. I think it's December 9th, I think, is the deadline. And then if it needs any cleanup or whatever, then it'll be, I think, 14th. But my assumption is that most of the stuff submitted on December 9th, that'll be kind of the final draft of things. So we're getting into the final sort of drafting of this thing now. But you should have most of the information you need in hand as you begin to, you know, convert this thing into a manuscript with narrative elements.
I'm sure there's a huge variance, but what's your typical span of length?
What's that? I'm sorry, length?
Yeah.
Yeah, it varies. I mean, I think it's hard to envision how you could, you know, do all the elements of this and do it in less than, at the very minimum, maybe, I don't know, 12, 14, 15 pages. Some of them have been a lot longer. I don't know of any that have been much shorter than that.
Thank you.
Because it's, you know, it's an APA format. It's double spaced. It's, you know, 12 point, you know, Times New Roman sort of thing. And so it's, you know, 12 pages of that is not very much. Yeah. And please double space and number the pages, please, so that I can keep track of what I'm doing. Plus, that's APA.
Do you have like an old student example? Sometimes it helps just to see kind of what people have done in the past.
Yeah, I do. I will, after we get kind of, I tend to wait until the first sort of complete draft you've put up, but I'll go ahead and pop that up. I've got to go back through the examples I've used in the past, make sure I've pulled decent ones. But I'll try to put that up over the weekend too. You know, a couple, 3 examples.
Thank you.
And hopefully the action plan feedback will be tomorrow sometime. Plus, it's supposed to be really cold tomorrow. I think about up here, about maybe it might get to 40 with a 20-mile-an-hour wind and, you know, 19 tomorrow night, something like that. So I will not be going anywhere anyhow. Other questions, other comments, thoughts?
When you were going through percentages and stuff tonight, is that something we'll be doing as part of our methodology section?
No, that's just the introduction to quantitative logic, because this is I'm hoping that as you kind of build your methodology, it'll help you kind of think about what kind of data you might be collecting.
Okay.
And, you know, so that can kind of hold off until we do qualitative piece next week, and then you can kind of think about what kind of data you might be collecting to put that in your methodology. This is going to be, the methodology piece is going to be probably the sketchiest piece of your whole thing. And by sketchy, I'm not talking about a value judgment. This is a sketchy piece of work. No, I'm saying that, that'll be the piece that's probably the least well explained, because this is kind of relatively new to you, if not brand new to you. Other question? Now, you may find that there are some elements of the outline that don't fit everything that you're doing. And if that's the case, at least include that element title and let me know, why you don't think it worked for you. Other questions, thoughts? You can always email me if you need to or whatever.
Dr. Ball, I emailed you my action plan. Would you rather me put it in the As You Learn as well, or just it's okay?
Well, yeah, you better because I think I recaptured everything I lost, but I can't be 100% sure that I didn't lose some things.
Okay.
And download files and things like that. So stick it up on As You Learn. Kind of ignore the timeline thing on As You Learn. It just stick it up there if you would. Yeah. Okay.
I'm not seeing the outline on As You Learn. Can you point me in a more specific direction?
Okay.
I'm sure I'm just looking over it.
Yeah. Make sure I'm in the right section. Yeah, if you go into the first section, right below where it has the Zoom dates and things like that, you'll see a school improvement project outline.
Yes, I got it.
Yeah. Okay.
Thank you.
All right. We good? All right, folks. Have a good rest of your evening and go off and do what normal people do. And I'll see if I can get these videos squared away so I can load them up and all that sort of stuff. And any questions or anything, please give me a yell. I'll try to put up some, I will put up some examples. I'll get your feedback to you and open up a couple of new sections of some content, a little bit more resource on qualitative stuff so that you'll have that to kind of look at as for next week.
So we're meeting next week and then again the 21st, correct?
Yeah, and then that's it.
Okay.
It's all writing and projects and feedback and whatever.
So for this next assignment that's due on the 21st, we do sections 1, 2, and 3.
Yep, give it your best shot. Yeah, give it your best shot. And with the understanding that this is not a polished final sort of thing, and there may be some sections where you haven't really thought through how you're going to do that or whatever. And so if there's blank pieces in it or whatever, that's fine. Just let me know where you think you're going with it. Yeah. Everything's a draft until the final draft. And even that's a draft. Okay, folks, I guess I will see you next week. And if you need anything, yell at me. Well, email me in all caps. I guess that's yelling in email fashion. Even if we need to meet in Zoom, to talk about stuff one-on-one, that's fine. Just let me know. All right. Y'all have a good evening, and I will see y'all next week.